Good afternoon, students. Now we will move on to triple integration. So we'll see here how to integrate using triple integration, and before that we will see the coordinates of a point in the three-dimensional space or in xyz axis. Okay, xyz plane. So as you know, suppose we consider this diagram. So here the x-axis, y-axis and z-axis, as you know, these axes will be perpendicular to each other, and suppose P is a point in this plane. So here this yz, this is yz plane, this is xz plane, and this is xy plane. Suppose P is a point in the zy plane, then what will be the coordinates of these points? That is P, x, y, z in Cartesian system. What will be these x, y and z in spherical system and in cylindrical system? We will see that. Okay. So here in Cartesian system, this is P, x, y, z. In spherical polar system, spherical polar system, this will be x will be r sin theta cos phi, y will be, x means this OL, this OL will be x, that will be r sin theta cos phi, then y, that is your on is y, that y will be r sin theta sin phi, and z will be r cos theta. Okay, z means this PM, perpendicular PM will be r cos theta in spherical polar system. Then, and as you know, r square will be x square plus y square plus z square, then phi, angle phi will be tan inverse of phi by x, and so on. Then the same coordinates x, y, z in cylindrical system, it will be x is equal to, means suppose this PM you know it is z, then say OM, this OM I am taking as say rho, then this x is given by rho cos phi, okay, then y is will be rho sin phi, and z will be z. Okay, so x will be rho cos phi, y will be rho sin phi, and z coordinate z will be so let's say we represent it by small z. So these are the systems, these are the points x, y, z in both the system. Now when we want to integrate, that is, say for example, consider a function f of x, y, z defined over a finite region, say V, in a three-dimensional space. Okay, so here x, y, z, three variables are there. Then triple integral of this f x, y, z over a region V is given by, what you will do here, we will integrate it, f of x, y, z, dv will be all the three dimensions, so we will write dx, dy and dz, and here you will write the limits, means here depending on this function, means depending on the limit we will integrate this. Okay, now suppose here it is f of x, y, dx, dy, dz, then if you are integrating this first, then here the limit of x will be in terms of y and z, means you will integrate this term first with respect to x, then you will keep y and z as constants, and limit of x will be in terms of y and z, say x equal to f1 of yz and x equal to f2 of yz. Then here we integrate this with respect to y, so y will be some function of x, and say y equal to say phi 2 of x. Then and this z will be some constant, limit for z will be some constant, z equal to a to z equal to b. Okay, so this is triple integration, means you will do or you will integrate as per the limits. You will see the limits, then you will see this one, then as per that we will integrate. Say for example, if I am doing say 0 to 2, 1 to 2, 0 to yz, xyz, dx, dy, dz I want to integrate, then this will be, now here dx is given. Okay, here dx is there, then this will be, and here yz is there. So this you will integrate with respect to x. This value will be x and this value will be x, because here you cannot integrate this with respect to y, because y is a limit here. I mean in limit there is y, and you cannot integrate this with respect to z because z is there. So here x is not there, so you will integrate that with respect to x. So here this is 0 to 2, 1 to 2, integrate this with respect to x, means yz is constant. Okay, yz is constant, then integral of x is x square divided by 2, limit 0 to yz dy dz. Now that is equal to 1 by 2 is constant here, 0 to 2, 1 to 2, upper limit yz into upper limit yz the whole square, means y square z square dy dz. Okay, now you will integrate this with respect to what? Here 1 to 2, 0 to 2. So both are constant, so you can either integrate this with respect to y or with respect to x, because there is no variable here. Okay, suppose I am going to integrate this with respect to y, so z will be constant there. Then this is 0 to 2, then z into z square is z cube, y into y square is y cube, integral of y cube is y raised to 4 by 4, limit 1 to 2 dz. So that is this 1 by 2 and 1 by 4 is 1 by 8, integral 0 to 2 z cube into 2 raised to 4, 16 minus 1 raised to 4. So 16 minus 1 is 15. So 15 dz. Okay, then this is equal to 15 by 8, integral of z cube is z raised to 4 by 4, 0 to 2, so that is 15 by 8 into 4, z raised to 4 means 16, 2 raised to 4 is 16. So when you cancel this one, you will get the answer as 15 divided by